And I just wanted to see if we could do this ed puzzle in place of being together and using sticky notes and bags to understand variables. So we're going to explore this using this interactive tool, and hopefully you can get something out of the ed puzzle to help you kind of process what's going to happen as we get into this part of coding. So just to kind of start off with, let me give you some information that we're going to understand variables, which is just a value. And it kind of falls into two categories. The first of which would be numbers that we're going to denote on these yellow sticky notes. And that's any kind of digit. And then the second one we call strings, which is just made up of characters. And it's essentially like words or phrases. And we often will see it with quotation marks around it so the computer knows when it starts and stops. So you can have words like hi or hi there, but you can even put numbers like 1, 2, 3 or see you late with an 8 to denote a string or an expression. And we're going to put those on red sticky notes as we go. The computer will also look at operators the same way a calculator does when it's dealing with numbers. So if you use the expression 2 plus 3 in computer language, that will evaluate to or equal 5. And the computer understands that 2 plus 3 is 5. Just to kind of get an understanding, stop here. I want to make sure you're listening and evaluate this expression. What's 5 minus 1? Take a second to do that. So then let's look at what happens though with other types of operations. If you look over here on the left-hand side, you're going to see we can add numbers together and it will evaluate. We can subtract, multiply, divide. But if we take two strings and we put them together like 4 plus ever, that's going to evaluate to the word forever. It puts everything in the string together with no space. If we take a string like gr, that sound, and we put it with 8, it's going to convert all of this into a string because it doesn't know how to add letters to numbers, but it just makes it an expression. Great. gr8. Same thing happens if you do first a number and then add day to it. It becomes 2 day. So over here on the left, let's try it. Let's see what happens when we say, okay, 4 plus 5, we know what that is. You're going to have to answer then. What happens when we just take 10 minus 9? What happens? That's just 1. You probably got that right. If we take tree plus house, we get tree house. What happens when you take your plus r? You give me the answer for that. And then also what happens when we take the variable 3 and we add d to it? Did you get your and 3d? If you did, good job. Let's keep going. So then we talk about this idea that we can have variables and place them into a holder like a plastic bag, but we have to give those holders names, and the names can't have quotation marks on them or spaces, and they have to start with a letter. So this bag we named Zip, and if we wanted to say what was in it, we would have to say zip equals 2, and it would put the sticky note in yellow, notice, with just a 2 in it. Let's say we name this bag WAP. You can name it whatever you want as long as it starts with a letter and doesn't have any spaces or quotations or anything. If I said WAP equals hi, then I've essentially put inside that bag a sticky note. It's a string. Notice its color with quotation marks, hi. You try that now. I'm going to pause the video here and ask you, what do you want to name the bag Zip to? Put anything that you want in there, just to get familiar with how you would go ahead and assign something inside a variable. Okay, you could have done whatever you wanted with that last one. Let's look and see what happens when we want to evaluate variables and expressions. So let's say we have a variable called Zip, and it has a 5 in it. And then we decide, well, let's take 3 plus Zip. What happens when we take 3 plus Zip? Oh, we now have 8. So if we say that, it's like saying 3 plus 5, Zip becomes just a variable and we replace that. And if we take Bop or Boop, and we say that's high, and we add it to zip, notice because we have a string and a variable, it'll just evaluate to high 5 and it becomes a string. Let's see what happens here. You're going to help me do this one. So if we have in here, in this variable boo, the number 4, and we want to then say 3 times boo, what do we end up with? Hopefully you came up with 12. Let's try the next one. You have rar plus EP. What's that going to evaluate to? Did you get beep? If you did, good job, because this variable had BE in it, and when we add two strings together, it just pushes them all together to give us one more. Let's try this last one. What happens when we take the variable rar and add boo to it? What's that going to give us? If you came up with B4, great job. You are starting to get the hang of this. If you didn't, don't worry. You can have more opportunities to figure this out as we go. Let's talk about how we actually use programming now to control variables. So we're going to have some stuff in here highlighted. Strings will probably show up in pink, numbers will show up in yellow, and that's just going to help you remember that they are different. So let's create a variable. So now notice I've introduced this idea of line numbers, because in code you always are going to have a line number that tells the code how to sequentially follow one thing to the next. And then we use this command that said create a variable, var, and let's name it POW. So that's essentially like making a plastic baggie with POW on it. If I wanted to then run some code that assigns an operator something, I could first then say, let's create the var POW. Oh, there it is. Now I've got a bag with POW on it. In it, let's evaluate that to 3. Or assign it the value 3. So now I've put a sticky note. Notice it's a number, so it's yellow, of 3 in there. But then what happens if I want to later down in my sequential say, well, what if I want POW to be 5? What happens then is that the 3 has to go away. It gets thrown out, and the POW bag can only have one sticky note in it at a time. So the new one gets the value 5. And that's going to become crucial for us as we go through coding to understand how we can replace variables with different evaluations or different things that they can be assigned. Let's take a look at one more example then. Let's say in this example, I start off in my 0 line of code here by creating a variable called pizza. So that's like making a bag with pizza on it. I then on my next line of code, a 1 here, decide that I want to give that variable the value 3. Notice it's a yellow sticky. I'm going to put that yellow sticky of 3 in the bag. Then on my next line, I said, oh, okay, why don't I create another variable called tacos? So I'm going to create a bag called tacos. But then I decided to come down and say, well, I want to change the value of pizza to yum. When I do that, I have to throw out the 3 that was already in there and replace it with a sticky note. In this case, in my language that I'm using in code.org, I can go ahead and just switch it from a number to a string like yum, and I just change the color of my sticky note. And then I want to say, okay, well, let's lastly on line 4 assign the best to tacos. So then I just create a sticky note with the best in quotes and throw that in my bag called tacos. There we go. So let's try one more thing where we see what happens, and then you're going to do some work. In this case, on my 0 line, I went ahead and created the variable POW. Here it is, and now there's my bag. I then wanted to evaluate it with an expression 1 plus 2. So in the bag, it's like 1 plus 2 is 3. I put that 3 in there. But on my next line of code, I say that I want to evaluate it to 3 plus 4. Since I can't have both, or these two lines don't interact, and this one comes after it, it just throws out the 3, and now says that 3 plus 4 is 7. So POW, if I looked in my bag POW, I now would only see 7. So let's take that idea. You may have to pause it and think about this for a second, but that's okay. You're watching a video. Let's then go ahead and look at this. Take a look at this code read through it with yourself or with a partner and try and figure out what is going to be your variables and what's the sticky notes that are going to be in this variables at the end. So take a minute to do that, answer your ed puzzle, and then you can check your answer when you're done. Did you come up with Zhao is going to be 4 now and fly is going to be 9? If you did, you're right on track. If not, don't worry, still going to have more time to practice it. Let's keep moving. We're going to take a look at some stuff now, but we're going to stop highlighting the strings and the variables with the numbers in them, just so you can kind of practice it on your own. So here's another example. We start off with the variable kit. So we create a bag called kit. We then assign that the number 1. So we put a sticky note 1 in there. We then create a variable called boo. Notice we still have the variable kit, that's 1, but now we also have a variable named boo that's empty because we haven't given it any value to put into the bag. But we say, oh, well, boo is just going to be kit plus 1. So whatever was in kit, which is 1 right now, we take and add 1 to that. Okay, boo now has 2 in it, but kit still has 1. And then later we can come back and say on our last line, oh, well, kit has the value 5, so it'll replace the 5, throw out the 1 that was in kit, but the value of boo doesn't change. It just stays as 2. And that's like a very important concept in coding, that we're not really talking about mathematical expressions. We're really just saying that we want to assign a value into a box, or in this case, a plastic bag, and it stays in there until we tell it to otherwise change. So let's take a look at this code. See if you can pause your video, walk through it, and then answer what the evaluation is going to be at the end. Did you get fuzz is going to be 11 and clip's going to be great? If you did, you really got the hang of this and you're ready to move on. If not, don't worry, still have more time to practice. Let's keep moving. So let's just talk about some takeaways. Numbers and strings are 2 different types of the same values. Like, notice that we put numbers in yellow and strings in pink here, but in your code, the only way you're going to be able to tell the difference is that a number doesn't have the quotations, and any string should always be followed with quotation marks. You can evaluate numbers with any kind of mathematical expression. For the example, 10 divided by 2 will give it the value 5. The computer uses it just like a calculator and does that. But with strings, the only thing you can do is add them together and it just smushes the strings together. You can assign a value to your variable and then change it, and it will just throw out the old one and that'll be deleted forever, and put the new variable in there. Notice in all of this language that we're working in this language called JavaScript, but in this PowerPoint we use this backward arrow. We said that it's written that way, but in code and in your language of JavaScript, you're going to see that written as an equal sign. But it doesn't have the same properties of math, where once something is equal, it's always got to be equal. So it's more likely to be called is assigned the value, or is evaluates to, or is written as. Something to keep in mind as we go through this. So the command fuzz is written as here, where we say fuzz evaluates to fuzz plus 1. In math, that would mean that fuzz has to be equal to itself plus 1, which never can happen. But in programming, it just means make fuzz equal to whatever fuzz was already equal to plus 1. So good luck with that, and let's get some practice doing some coding in the next lesson.